So here an example of how the information gonna be stored in the machine using different way, big endian and little endian. So let's assume that a byte addressable machine with the 32 byte hexadecimal value of from 1, 2, 3, 4, 5, 6, 7, 8 with the information gonna be stored at the address 0. So in this representation, each digit require a nibble. So 1 byte hold 2 digits. Um, this hexadecimal value is stored in the memory as shown in the table below right here with the big endian and little endian arrangement. So you can see that address is in the first row. That's from 0, 0, 0, 1, 1, 0, and 1, 1. So with the big endian representation, we see that the most significant byte, that's a 1, 2, gonna be represented at the address 0, so that's the lower address. And the next most significant byte gonna be 3, 4, gonna be represented the next address 0, 1, and so on. On the other hand, with the little endian, we can see that the least significant byte 7, 8 gonna be represented at the lowest address 0, 0. And the second lowest byte 5, 6 gonna be represented in the address 0, 1, and so on. So let's consider another example where a computer uses 32-bit integers and the value to represent different value in hexadecimals A, B, C, D, 1, 2, 3, 4. Another value of in hexadecimal, that's 0, 0, FE, 4, 3, 2, 1, and the last value in hexadecimal, that's the 1, 0. And we want to store the information sequentially in the memory, starting at the address of 200 as shown in the shown the table below. So you can see that the first column, that address starting at the address of 200 and so on. With the big endian representation, you can see that the information of the first number right here and the most significant byte AB gonna be represented first at the lowest address 200, and the in the next address 201 gonna be used to represent or store the information of the second most significant bytes, that the CD, and so on. So you can see that from 200 to a 203, that represent the stored information of the first number. And with the next for address gonna be used to store information of the second number. That's a 00. That's the most significant byte in the second number. And FE 43 and 21. Okay. With the last number, we can see that some 0 byte have been padded into the number because of the 32 bit. So we don't have the enough information, so some 0 byte right there already padded. So basically we have the 3 0 byte have been padded, and the last byte gonna be represented at the address of 20B. Okay, so that's gonna be corresponding to the variable 10 right here. So on the other hand, if we use the little endian to represent this number, the least significant byte gonna be represented first. So we have the 34 right here, gonna be represented or stored in the address 200, and the next least significant byte gonna be represented in the second address 201, and so on. So the first for address in the memory gonna be used to represent the first number A, B, C, D, 1, 2, 3, 4, right here. And the next four address gonna be used to the second number. But again, we can see that the least significant byte gonna be represented or gonna be stored first in the address 204. Okay, 25, 21, 34, FE, and 00. So the most significant byte gonna be represented last in the second number right here. And with the last number, so we can see that this is the least significant byte gonna be represented first. So we can see that 10 gonna be stored in the address of 208. Okay, and the remaining padded 0 byte gonna be stored in the remaining address from 209 through 20B. So we can see that there's a difference between big and little endian representation. So basically, um, we can see that the big endian is more natural to most people, and that's make it easier to read in hexadams. Also, by having the high order byte come first, you can always test whether the number is a positive or negative by looking at the byte at the offset 0. Um, this is in comparison to the little endians, where you must know how long the number is, and then must skip over bytes to find the one containing the side of the information. So basically, the big endian machine store integer and string in the same order and are faster in a certain string operation. However, the big endian also have disadvantage. For example, a conversion from a 32-bit integer address to a 16-bit integer address require a big endian machine to perform addition, and high precision arithmetic on little endian machine is faster and easier. And most architecture using the big endian scheme do not allow words to be written on non-word address boundaries. For example, if a word is a 2 or 4 bytes, it must always begin on an even number by address. So this is gonna waste the space in the memory, and the later endian architecture, such as Intel, allow odd address reads and writes, which make programming on the machine much easier.